All right.
Hey, James, you're good to go.
All right. Well, I'm going through the earlier slides. All right. Welcome aboard, everybody. We got a lot of information to cover in the next 40 minutes or so, so we're going to jump right into it. But as Laurie said, please feel free to jot down your questions as they come up. A little about how we'll be going about things today. I'll be talking background and philosophy, then I'll turn over to Brett for the landscape, the scale, planning and prioritization. I will cover the implementation and challenges, and then we'll finish up with Brett as we talk about ways that we measure success. So into the background and philosophy, a little bit about Eglin for those that don't know. A real important landscape from a conservation standpoint, the largest single ownership of longleaf pine, and also the largest contiguous stands of old growth, and of course longleaf pine being one of the most pyrogenic landscapes in North America, a lot of need for prescribed fire. But Eglin is also one of the busiest military reservations in the country, so there's a lot going on, and it's a lot different than prescribed burning on a national forest. And we'll get into more of the challenges that surround some of that as we go further into the presentation. So a little bit about why we burned. The last three bullets should be very similar to other places with large longleaf pine landscapes, wildfire risk reduction, and managing for federally listed species, and of course, as mentioned before, the need for frequent fire in the longleaf pine ecosystem. But also on Eglin, we're supporting the warfighting mission through sound environmental stewardship and long-term range sustainment. Essentially, as long as the military and our program takes good care of the landscape, as long as we're good stewards, we maintain flexibility for the military mission on Eglin Air Force Base. A little bit about our philosophy, and some of these individual bullets I could give a whole presentation on, but I'll try to keep things kind of brief. Looking at long-term fuels management, just trying to keep fuels light enough to so that we've got options. We do have a lot of wildfires on Eglin, about 100 a year, and if it's an area with reduced fuel loadings due to prescribed fire, that gives us a lot more options for how we manage those fires. Another thing that's a key part, and Brett will go into more of this when he talks about our burn prioritization, is that we really have no fixed return interval. We'll burn according to ecological drivers and need. Also, frequency leads to more frequency. We have a saying, we say, the more you can burn, the easier it is to burn, and the easier it is to burn, the more you can burn, and it's all about frequency in a longleaf pine landscape like we manage. And bearing that in mind, there's no such thing as perfect burns. Sometimes we'll burn and it'll be on the cool side, maybe only 50 or 60% will carry fire. Other times it may be a little on the warm side, but rather than trying to make every burn perfect, we just try and get out on the landscape and get fire going as often as we safely can. And the final bullet is uncertainty always increases fire return interval and never increases frequency. And that goes back to why we do not have a fixed return interval. If you're saying that we're going to burn an area every 3 years, well, what if there's a hurricane? What if there's a drought? And all of a sudden you can't get that area burned. The next time you go in, you've got a heavier rough, and it goes downhill from there. So we try and burn as often as we can, bearing in mind that uncertainty, things that come up, including military mission, can make it hard for us to burn certain areas. And we joke about, it's all about the acres, but on a landscape like Eglin Air Force Base or some of your other really large fire-dependent landscapes, acres really do matter. And I don't know why we went back to the first slide here. So about 270,000 acres of fire-dependent acres are prioritized for burning on Eglin, and our stated objective is we want to average at least 90,000 acres of prescribed fire per year. We have to do that just to maintain the Eglin landscape. So, that comes out to an average of a 3-year fire return interval. But frequency is just really important for a number of reasons. By burning frequently, that gives us the flexibility of burning in all seasons of the year because we've got fuel loadings under control, ties directly in with the number of burns implemented, and it also is indirectly tied to severity. As long as we can burn frequently, we keep the fuel loadings under control and can keep from doing damage with our prescribed fire program by killing, preventing the death of canopy trees and that sort of thing. So frequency really, really is important. A little bit about the program, and Laurie referred to some of this. We have had great success at the Eglin Fire Program over the course of the year, steadily increasing. Looking at the past 10-year trend, you can definitely see the drought years where we had serious wildfires back in 2006, 2007, and actually 2011 we had a lot of wildfire activity as well. The 2013 numbers are just in. We actually work by fiscal year, which is October 1st, but we did burn about 104,000 acres in 2013. And at this point, I'm going to turn it over to Brett, and he can talk about landscape.
Before you turn it over, just make sure that you have clicked follow, James and Brett. Follow in the top right-hand corner of next to your slides, just to make sure that we can follow along with you. I think you just did that. So hopefully you are now on the right slide, landscape scale planning and prioritization.
Okay, we got it. Hi, this is Brett, and now we'll explore how we plan and prioritize burning at a landscape scale on Eglin. And 2 points I want to emphasize. This is the path that we chose as land managers. It seems to be working well for us. Elements of it may or may not work well at your landscape, so take what's useful. And this is an iterative and adaptive process, so we're continually re-examining, adjusting, and monitoring so that it's a dynamic process. So when we talk about longleaf, due to loss and fragmentation of the longleaf ecosystem, the reintroduction of fire into relatively smaller land holdings can be approached similar to gardening. Much like choosing the right amount of water and fertilizer for each bed in a smaller garden plot, a land manager in this situation may be able to wait and choose the desired conditions to burn each of their fire units and meet objectives. They can choose the season, the right weather conditions, the fuel moistures they want to be burning under, and have a lot of flexibility on which day they choose to burn. For larger landscapes like Eglin, managers have no choice but to approach fire management like commercial farming. We have to burn larger blocks, often across multiple fuel types that may or may have different prescriptions, take advantage of every potential burn day and every prescription window. We need to be looking at every day as a potential burn day until proved otherwise. And we have to focus on burn regime, like James said, instead of perfect burns, looking at multiple burns, 5-10 years down the road, trying to get 2 or 3 or 4 burns into an area, and not hung up on, well, did it meet the exact objectives we need on a given day. So how did we get from where we were to where we are now, and really get our acreage numbers up and prioritize where we want fire to be on the landscape? The problem we all have as land managers is we don't have enough people, equipment, and time typically to do all the burning, all the land management we need to do. So at Eglin in 1998, up until then, we were still trying to manage every acre at Eglin with fire. Everything was important. There was no priority. And at the same time, we had very limited resources. So through 2002, the 30-year average was approximately 38,000 acres of fire across the landscape in a given year. So our resources were spread too thin, we were meeting few conservation objectives, and as a result we had an average of about a 6-year fire return interval across fire-dependent acres on Eglin, and we were losing ground. So we decided to put a process in place using managers and researchers, other fire experts, sat down, identified key factors that determine the need to burn. This was done in a workshop setting. Developed GIS remote sensing data layers to directly or indirectly represent these factors, and then polled the managers and said which of these factors are the most important. And we actually assigned weights to these factors, adding up to 100%. And then we look at this model each year and through time, and we use manager intuition and a decision support system, basically a fire database that I'll talk about a little bit later, to modify the model over time. So this is a dynamic model. We're manipulating the inputs on an annual basis, and we continue testing the assumptions of the model with our monitoring program. So this is how the weights, both the factors and the weights play out in the model. This is what we coined our burn prioritization model. It's a spatially explicit weighted overlay that we process in ArcGIS Model Builder. And if you look at the inputs, here there's 14 inputs. The managers decided time since burn was the most important driver for fire in our longleaf sandhills and flatwoods on Eglin. So it received the greatest weight. Our monitoring data has shown that a dramatic decrease in plant diversity and loss in positive plant indicator species after about a greater than 5-year time since burn in our sandhills. So we really want to emphasize if an area is slipping away, getting to be 5-6 years since burn, that we bring it back into rotation. Our flatwoods areas tend to be in urban interface areas and are a lot harder to burn, mainly for that reason. There's a narrower prescription window for our flatwoods, so we've really increased the weight in those areas. The CCA is our core conservation area. That's part of the landscape that the managers have designated as priority for restoration efforts, and so that's where we focus a lot of our management. It gets 5% of the model. Species drive this for regulatory reasons. The red-cockaded woodpecker, the flatwood salamander, they both get increased weight. ECM tier change, that I'll go into that a little bit later when we talk about our ecological condition model. And timber stand improvement, both mechanical and chemical. This keeps us integrated with the forestry program, make sure we're following up their forestry treatments with fire. And we're really targeting sand pine. That's further down, but that's one of our native fire-sensitive species, or at least different fire regime, and has been invasive on Eglin. And so we include that in the model. So this is the model as it stands today, and we'll go through how some of these inputs work. So this is a layer, time since burn. We're fortunate on Eglin to have an extensive fire database that goes back to 1973. So we have about 30 years plus of fire history data. The resolution of the model is at a 30-meter pixel scale, which matches the Landsat thematic mapper satellite resolution. And weighted values are scaled so that no weight is given at 1 year time since burn. So if you look at the graphic in the upper right-hand corner, kind of, it has a scale at 1 year time since burn. An area or a pixel doesn't get any weight, and then that scales up over time up to 4 or 5 years since burn. It gets full model weight. And the cooler color here, cooler colors are more recent time since burn. So dark blue is 1 year time since burn, all the way down to the bright yellow areas are long since burned. So we give high weight to areas once they go past 5 years since burn, and they get a full 37% of the model if they get to that point. After 13 years since burn, they start losing emphasis, start losing prioritization, and at 20 years since burn, they get no model weight at all. At that point, we feel like other treatments, chemical, mechanical, are going to be necessary before fire alone is effective in restoration. Another example, this is our RCW management emphasis area. So a pixel that falls within the yellow gets all of that model weight, all 5% of the model. Areas in black that aren't within that management emphasis area get 0 model weight for RCW. Land cover, if a pixel is within a longleaf cover type, and we classify this satellite imagery with NDVI and supervised classification. But if it's within a longleaf cover type, it gets prioritization and model weight. If it's in areas that are not priority for cover types that aren't priority for burning, it doesn't get any of the weight in the model. Those are just 3 examples. All those layers, 14 layers, are then overlaid, and respective weights are summed for a given 30-meter pixel. So areas that are darker red had multiple inputs and have multiple drivers for fire priority, and so those are the areas that during this model run had the greatest priority for burning based on that model. The initial model run produces a raw output at the 30-meter pixel resolution. Like I said, darker areas are areas that receive greater weight across multiple layers, and as opposed to lighter colored areas, and are higher priority for burning according to the model. So that's the raw output. We can then scale that up to road-bounded polygons and creeks, or streams that we feel like will hold fire. We call these secondary burn blocks. They can be burned through ground ignition or aerial ignition. And again, the darker areas by this model are saying those are high priority for burning this year. We can then scale those secondary burn blocks up to larger scale primary burn blocks, which we consider appropriate for aerial ignition burns. They're usually 1,500 acres or greater in size. And in any given year, we overplan what we think we can burn. We asked the model to produce 120,000 acres of primary burn blocks and about 38,000 acres of secondary burn blocks. So that's 150,000 acres, and we actually hope to burn 100 to 120,000 acres. And we overplan to hedge our bets against uncertainties like James talked about, weather and missions, and gives us greater flexibility to burn somewhere any given day if missions are restrictive in a certain area. I'll now turn it back over to James to go through.
All right, thanks, Brett. Move on into the implementation, and like the earlier slide on philosophy, each of these bullets it could be a presentation into itself. The strategic burning has to do with really looking at how blocks can line up. You know, on some days it may be more strategic to use your burn crew to burn a long, narrow 200-acre block rather than 500 acres somewhere else if that long, narrow 200-acre block is going to set you up for a 2,000-acre burn the next day using a helicopter. So our burn bosses, fire planners, huddle around the map a lot, looking at weather forecast and figuring out the best way to capitalize on any given burn window that we've got. I also done a lot to streamline our planning process. Even though we are a federal agency, if you look at a burn plan for Eglin Air Force Base, it's 10 or 12 pages of maps and a checklist, as opposed to some places you'll go that a single burn plan may look more like a book. So we really work hard on streamlining the planning process as much as we can so that we can capitalize on the opportunities that come up. The spatially explicit management objectives, you got a glimpse of that in what Brett just talked about with the burn prioritization model. That's one of the tools that we use. He also mentioned preparing to burn more than you think you can, just to allow that flexibility. I think we've got 160,000 acres on the map planned this year, realizing we won't do that, but having those extra areas prepped and planned for allows us to jump in on them if we get a narrow window. The attitude is really important. Prescribed burning is, other than the occasional webinar, the single most important thing that we do on the Eglin landscape, for all of the reasons that we talked about earlier. And I will talk in a little more depth about aerial ignition here in a bit, because I know there's interest in that tool among the group. So an important part of being able to get fire on the ground is really finding ways to expand the prescription window. And essentially every year we'll make sure that we've got a few one-year roughs that are included in the burn planning. And that allows us to go out and burn those one-year roughs on days when we would not be able to safely burn in other places, and actually get some great fire effects going in and burning these one-year roughs, again, when we cannot burn more difficult areas. Working on early starts, sometimes we just have to do smaller blocks that we can finish up while we've got a narrow prescription window. Adjusting firing patterns, and there's, again, we could talk a long time about that, but looking at different ways you can fire an area to keep the intensity to a level desired. And also, whenever the weather allows, we will do some night burning, and often with really spectacular results. We'll talk a little bit more about aerial ignition. Just real quickly, for those that aren't familiar, you'll see this is a Mark III ping pong ball machine, as we call it, or PSD, plastic sphere dispenser, mounted on the side of a Bell 206 helicopter. You see results of a prescribed burn, and the what we call the ping pong balls themselves, actually a plastic sphere with potassium permanganate. They move through this machine, as we'll see in a short video here in just a second, actually injected with glycol and dropped out of the chute to land on the ground. There's an exothermic chemical reaction, and they'll burst into flames anywhere from 20 to 40 seconds after they're injected with the glycol. A little bit about aerial ignition. For large burns and large burn programs, it is much less expensive per acre than doing it by hand. Typically, for these large burns, 1,000+ acre burns, helicopter burn cost about half as much as running all those people through the woods. Even though it's $1,000 an hour, you can burn 1,500 acres an hour with the helicopter. So it's an inexpensive tool if you've got a large burn program. It's also safer because you do not have to have people in the woods, with all the dangers that go into, stepping in stump holes or, working ATVs in the woods. Great for smoke management as far as being able to get a lot of thermal lift. You can get a lot of fire on the ground in a short period of time and really lob a smoke plume up, and oftentimes even break through the mixing layer so that the smoke does not cause problems downwind. Allows you to really hit those prescription windows because you can get large burns done in a short period of time while you've got the proper weather conditions to do that. And aerial ignition is the only way that we're able to meet our acreage goals at a place like Eglin. And next, Laura, I guess if you can boot up the video clip for the plastic sphere dispenser machine. And I think it's time for a drum roll, because I think this is the first time that a video clip has been attempted with the thing. Lori, I hear sound, but I don't see a picture.
Huh. I think it's playing on mine.
Okay.
If the audience could let me know if they're seeing the clip.
Yeah, because I'm not seeing it on mine. If the audience is not seeing it, let's go ahead and just skip the video clip.
Well, I can give it one more try. Let me give it one more Let me give it just one more try.
don't know, Laurie. I'm not seeing anything on this end. Can anybody in the audience see the video?
Type in the chat room if you can see the video.
Lori and James, this is David. It looks like in the chat messages a lot of people are seeing it, but they don't have audio. That's what I can see on my end as well.
Okay, well, what we're looking at is just the operation of the ping pong ball machine as it's mounted in the helicopter. So let's go ahead and stop the video there, and we'll move on with the slides. So Laurie, is the video stopped?
It has stopped. It's back to you.
Okay. Okay, well that was partially successful, I guess. A little bit about the aerial ignition. About 2/3 of the acreage on the Eglin is burned using aerial ignition. Our average burn block size is about 1,600 acres, though we have burned blocks considerably larger than that, up to close to 5,000, actually 5,200 acres. Typically 4 to 5 balls per acre is a target that we shoot for. That will vary some depending on objectives, size of blocks, etc. Our standard distance is about 150 feet between drifts, but if we get an early start, it's light fuel, sometimes we'll widen that out to about 300 feet between the strips. The helicopter's flying 40 to 50 miles per hour. And as mentioned before, the total cost averages about half that of ground ignition. But one thing to be aware of with aerial ignition, it's not a panacea. There's a learning curve to it. Things can happen very rapidly. Sometimes it takes a while for the fire behavior to start picking up, and sometimes it has happened that by the time you realize that it's going to be too hot, you've already set 1,500 acres on fire, and there's no turning it off at that point. So almost any large program that has started using aerial ignition can show you some areas of standing death where there were some underestimations or decisions made. Not, like I say, things just happen very fast with a helicopter, so you have to be really careful to make sure that you do it right. And this is an example of the kind of control that you can get if you've got a good pilot. This is actually the GPS tracks from the helicopter on a burn block on Eglin Air Force Base. And I believe this is set for 150 or 200 feet between drifts, but you can actually get some really, really consistent burns if you've got a good helicopter doing the work. And I guess if we'll go ahead, Laurie, and try this video clip again if part of the audience is seeing it. And we don't necessarily need to go through the entire video clip, but the thing I want you to look at in this video clip is, this is an aerial ignition, paying more attention or looking out at the fire behavior that's resulting. And I really want you to pay attention to the interaction between the different spot fires that are set, especially as they start burning closer together. You can see how the fire will become more intense where those lines of fire or pockets of fire pull together. So just a quick look at some of the types of fire behavior that you can expect from aerial ignition, and to give you a feel for the scale that these things take place. So Laurie, are you able to see the video on your end?
Yes, the video is going from my end. We're almost finished with it.
No, okay, well we'll let it, hopefully most of the audience can see that. It's not showing up on my screen, but that's okay. Once it's back to me, just let me know.
Okay, I certainly will.
Okay. One thing about aerial ignition or any large-scale ignitions, and you may see this later on the test, so pay attention. The typical the fire behavior modeling tools available to fire managers today, such as the Behave, Farsight, Behave Plus, really are set for, or they're designed to deal with individual ignition points and do not take into account and cannot predict the kinds of interactions that occur on an aerial ignition where you've got multiple sets. What you're looking at on the screen right now is a snapshot from a model run from the FireTech model, which is run on the supercomputer at the Los Alamos National Lab. And actually, just a plug for a really interesting project that we've got going on at Eglin right now. Eglin, myself, and Brett actually are working with the Los Alamos National Lab with grants that we received through DoD to develop some training programs using the FireTech model to mimic various prescribed fire scenarios, and you can actually see these different types of interactions. So something we're really excited about and should have a finished product out in the next 2.5 years, where we can actually give some training on advanced aerial ignition techniques based on this computer modeling. All right, talk a little bit about challenges that we face. On this sign, the live fire area, despite what you see, is not referring to the kind of fire that we're all familiar with. On Eglin, a live fire area means that people are shooting things in there. So unexploded munitions are definitely a challenge for us, both for wildfire response and for prescribed burning, across many areas of the Eglin Reservation, as well as just working around an active military mission. This is a snapshot of the various missions that occur on Eglin Air Force Base on a given day, and we have to figure out what all of these missions are every day, which ones are smoke sensitive, which ones we can burn close to, and we actually have to use this same software to schedule our prescribed fire missions in exactly the same way that an F-35 dropping a smart bomb has to schedule a mission. So definitely a challenge to implement a prescribed fire program in the context of a busy military reservation. Smoke management is a huge challenge. I mean, how can you burn an entire landscape without anybody knowing? That's the thing that you want to shoot for. Obviously, it doesn't always happen that way. On the left side of your screen, you'll see a snapshot taken of the standard notification that we give for a prescribed burn on Eglin Air Force Base. Tells where it is. Just use a V-smoke model run, projecting visibility at ground level at a quarter mile, half mile, 1 mile, and 2 mile visibility. And that's used as a planning tool. On the right-hand side, you see Eglin on the south, and you see other public lands to the north. And in this part of the world, a great burn day is when you've got right after the passage of a cold front with brisk northwest winds. So Eglin can also serve as a smoke shed for these other public lands to the north of us, which of course Eglin gets blamed for it, but so we have to manage smoke that we produce on Eglin, and also have to work with our partners to manage smoke coming onto Eglin, especially if we have high visibility or sensitive missions. Other challenges, this is just a picture of a complex burn block with a lot of dendritic creek fingers, and all of the yellow blocks are red cockaded woodpeckers that have to be protected, or cavity trees have to be protected during a prescribed burn. And you can imagine trying to burn this with a helicopter and having to have people in at those sites to protect it. Could be potential for a death trap. So really have to be careful in how we deal with that. And I'm going to turn it over to Brett again for the final part as we talk about managing or measuring.
So we're meeting our stated burn objectives. We've been hitting 90,000 acres plus per year over the last 5 years, so we're really happy about our burn objectives in terms of acreage, fire frequency, and but is this translating into a desirable fire regime at the landscape level and improved ecological condition? So I'll take you now through a brief look at a few methods we're using to measure success, measuring the success of our approach. So first of all, I mentioned earlier we have a fire decision support system. For every fire at Eglin is entered into this decision support system. It's an Oracle-based spatial relational database. All fires and their related spatial and attribute data are entered into this database, and then automated reports like the one displayed are generated in real time. As we enter a fire, these reports are real-time updates. And for this report, our fire data layer is compared with ecological layers of interest. These are either community types like Bagall, flatwoods, sandhills, seepage slopes, or they can also be species habitat layers like potential salamander habitat, RCW foraging habitat, and we can decide what layers we want to query or examine in terms of fire regime characteristics. So in this slide, we're looking at 2003 on the left, 2010, a snapshot from the DSS, and average time since burn. So across the landscape, our average time since burn in 2003, if you look at for Sandhill, for instance, was 4.65 years average time since burn. And in 2010, we got that down to 3.2 average time since burn across all sandhills. RCW 350, which is a management emphasis area, about 3 years since burn on average across the landscape in 03, and that got that down to 1.5 average time since burn, or 1.5 year rough by 2010. So it allows for this real-time comparison of selected fire regime variables. At a course scale, we can just look at average rough age. This is in our core conservation area, or where we prioritize longleaf restoration. In '98, which was a historic year for fire in Florida, across our landscape, the red, orange, and yellow colors are more recent, or 0 to 3 years time since burn, and the cooler to gray colors are longer time since burn. So in '98, if you average it across the landscape, we had a 10.5 year rough average within our core conservation area. By 2011, you can see a lot more red and orange and yellow across that same area. We got our average time since burn, or average year rough, down to 3.5 years across that core conservation area. More of a fine-scale way we measure success is with another model, and it's a very similar model to the burn prioritization model. It's the what we call our ecological condition model. And so in an approach very similar to the burn prioritization model, we designed a model based on, again, a weighted overlay in Model Builder in ArcGIS. The managers sat around, brainstormed which factors contribute most to ecological condition in our longleaf pine, sandhills, and flatwoods, and for which we have spatial data. So you have to have spatial data that goes along with each of these layers or factors you believe contribute to ecological condition. So if you look at the model inputs, sand pine is actually a negative input, or the more sand pine we have, typically the condition of the ground cover and the composition of these longleaf areas is compromised. So it gets 12% of that model. Longleaf and fire frequency both get most of the model influenced at 21%. We use red-cockaded woodpecker foraging habitat as an indicator of high-quality condition. Time since burn, LIS is least impacted sites. We get this from satellite imagery interpretation of disturbance, and evergreen oaks are also a negative indicator of ecological conditions. So all these get weighted and overlaid on top of each other. We've also got a field monitoring program that 2001 we put in 200 permanent plots across the Eglin Reservation. We use this to ground truth our condition model, and we found that based on field data, the condition model is about 70 to 80% accurate. So 7 out of 10 pixels are modeled correctly according to our field data. So now I'll take you through a chronosequence or a time lapse since '94. We back ran the model starting in '94, and then about every 2 to 5 years we'll take you through a sequence. We also threshold the raw model outputs into 4 tiers of condition. Tier 1 are the blue areas. Our reference longleaf pine sandhills, high quality. Green areas is Tier 2. They have longleaf, a decent fire history, but they're still in the restoration phase. Yellow areas are Tier 3, and they'll require a decade or more of fire, multiple fires to restore. May need a mechanical treatment. And Tier 4 is long since burned, heavily encroached with sand pine, so low quality condition. And this graph on the right shows the acreage change over time. So this is 1994, not a lot of Tier 1 or blue areas on the map. By '99, we start seeing an increase, especially around our most active test areas in the western part of the reservation. That's where we were getting a lot of wildfires up until this point, and that's where our highest quality sandhills were in '99. 2001, you start seeing a little more green and blue pop up on the map, indicating potentially landscape change, increase in condition in these areas. And the east side of the reservation starts having more of these high Tier 1 blue and green areas. 2005, 2007, 2009, we really started, I think that was the first year we got over 100,000 acres burned that year. So large increases in, according to the model of ecological condition. 2011, and as I previously mentioned, tier change, or the change of a pixel tier between years, is used as a model input for the burn prioritization model. So if an area is losing condition or losing drops a tier from tier 1 to 2 or 2 to 3, it gets re-input into the burn prioritization model as a priority for burning. So we use this model to actually inform where we prioritize fire. If we see a loss of condition or a gain in condition, we can deprioritize those areas. So 2011, last time we ran the model, we'll do it again this year. But looking back, well, this was '94, 2011, and the model's indicating great changes on the landscape, and our monitoring data is confirming that. Like I said, about 70–80% accuracy based on field data. We're also exploring other models. This maximum entropy is a machine learning model. Statistician with the Nature Conservancy helps us with this. And it compares training points. We feed it our reference sandhill monitoring plot locations. And we also provide the same data layers that go into the condition model. And it uses these as training points to predict all other pixels or areas that are likely to be reference sandhills. So all these green areas are modeled to be reference sandhills. When we use this model in concert with the ecological condition model from before, we consistently get accuracy greater than 80% based on our field plot data. And even with all these fancy models, I feel like the most satisfying measure of success still may be witnessing the ecological response to these communities to frequent fire firsthand as you walk through the old growth areas on Eglin. So if you ask managers that have been around Eglin for a while, they see this change on the landscape with our increase in burn acreage, ramping up our prescribed fire program, really getting a handle on aerial ignition. So it's bearing out on the landscape from all indicators we have. And at that point, we'll turn it back to Lori, I guess, for questions.
Okay, great. Now we do have time for questions, so I'm going to attempt to moderate these questions. If you want to go ahead and type your questions in the chat box now, we'll go ahead and take any questions we have from the audience. And while they're typing their questions, I have a question from my side. So, with such large-scale burns, do you work with other agencies and organizations on a regular basis?
Sorry, can you repeat that, Lori? Apologies.
Yes. So these are really large-scale burns with the helicopter burns, and I'm wondering, do you work with other agencies or organizations on a regular basis, for instance, with the Florida Forest Service?
Not regularly. We do have a very receptive program to what we call pyro tourists, or individuals or modules, or PFTC would be a good example. We invite all qualified prescribed burners to come to Eglin, work on task books, and or if they just want to join a burn or observe a burn, be a part of a burn. So we're very open to outside folks coming in and helping us. We do have local partners that occasionally come over from National Park Service, DEP, Florida Department of Environmental Protection, the Florida Forest Service occasionally, but it's not a day-to-day thing where we partner with them. There are some other burn areas in the region that we do partner with, multiple agencies, kind of an interagency burn, but that doesn't happen on Eglin too often because we typically have resources and folks we need most days.
Excellent. And since I don't see another question, I'm just going to sabotage this and ask one more question. With the tight physical constraints that we're receiving right now, are you having trouble convincing people that it's important to keep up the prescribed fire?
Not at this point. I mean, we're definitely affected by the tight fiscal issues, the budget crunch, the government shutdown. We were furloughed, and so it's definitely a constraint. But at this time, our budgets look secure for this year, and our leadership. One thing we've been very successful at Eglin is convincing our leadership the need for prescribed fire. So they're on board all the way up the chain to the colonels and general level, that on Eglin it's a fire-prone landscape. Their missions cause fires. If we can manage the fuels and meet the regulatory requirements of the Endangered Species Act, that it keeps them in business, allows them mission flexibility. And so they get it, and at this point we haven't had a lot of constraints. One constraint we have had is difficulty getting overtime, or we have limited overtime, and when you're trying to do a prescribed burn and you have to take a lunch break or leave at a certain time, it definitely can constrain how much burning you can get done, how you approach it. But that's been the only thing so far. It does concern us, though, as budget negotiations continue every 6 months.
Yes, thank you. And I see we have a couple of questions from the audience. We have Joe has a question, so I've given him moderator privileges, and he can now use his talk button, or he can type in the chat box, and so does Mike Zepko. So I'm going to hand the mic over to one of them.
Okay, and if they can let us know who they want to address the question to, I can hand the headset back to James.
Joe, we're not able to hear you. Would you be able to type your question in the chat box?
Hey Lori, this is David. There seems to be something going on weird with the chat box. I'm able to receive the direct messages from folks, but they're not going into the general room. So here's a question that looks like it came in from Mike Zepko. And I'm just going to read it directly here and let you guys interpret it. He says, on the side of the GIS for the helicopter, on the top of the helicopter, doubled back on the first few passes before going the full width of the track. Is that a strategy for testing a smaller area before going across the full tract, or was there a structure or some other reason for turning back halfway? So I think it sounds like he's just kind of getting into some of those initial passes, or maybe final passes, that the helicopter ran when you were doing ignitions. Could you kind of talk about that a little bit?
Yeah, this burn was actually done for a large research experiment called RX Cadre, which we didn't have time to get into in this presentation, but I think it was done for research purposes. Typically, we start with a black line or a baseline. We had a south wind this day, or maybe a southwest. And so the tighter lines to the north were part of that black line or reinforcing that black line. And then I believe it was for research reasons. There were either instrumentation in the plot that required that firing pattern, or that was probably the most likely cause. And then halfway through, we started going all the way back and forth across the unit. And it was about a 1,200 acre unit, or maybe a little more.
Okay, I have, I don't know if you guys are able to see it, but I have a couple other questions that I can see that came in on these side messages. And here's one that came from Caitlin. And she said, do you collaborate with other, actually two questions, do you collaborate with other federal military installations like Fort Bragg? And then her second question is it a misconception that at the federal level there is less liability than there is at the state or private landowner level? So I guess the liability are the issues that you guys have in terms of your burning and your smoke program.
On the first one, as far as collaboration with other DoD installations, historically we have not. We partner closely with Tyndall, but more recently Eglin became the Air Force Wildland Fire Center for all Air Force, managing wildland fire programmatically for the entire Air Force, all installations that have wildland fire issues. And so we're already starting to ramp up collaboration with a lot of bases in the southeast. We don't have as much interaction with Army, with forts and so forth, but we talk to them, but we haven't done a lot of burning with them or collaborated on burning. But we have we've had requests in the past from a number of those bases for the burn prioritization model and wanting to apply that. I think places like Fort Benning, I don't know if that played out. I think Camp Shelby in Mississippi, we went up there and talked to them. Camp Lejeune in North Carolina uses some modification of the burn prioritization program, or model. So in that sense we have, but we don't travel a lot and burn with other DoD installations, although we expect that to increase as being the Air Force Wildland Fire Center. And in terms of liability, we have the same requirements through the state as far as smoke management, as far as keeping fires under control. We're subject to the same laws and standards that everyone else is. We require all our burn bosses to be Florida certified burner, which gives us additional protection under Florida state law. But being DoD doesn't give us any special exemptions. We still have to get a burn authorization on a daily basis or when we're doing burns, and follow all state and federal laws. One nice thing is we do have a large reservation that we can work with, and so we're not always burning in the urban interface, but that's just a luxury, and it doesn't have to do with liability, I guess. I hope that answers the question.
That's great, and I'm going to have to stop now so that we can go ahead, and we're over our hour. There were a few more questions on wildlife and also on the Air Force mission. I have gone ahead and put Brett and James's email in the chat box, and so feel free to contact them. But right now I'm going to go ahead and finish up this webinar, so I want to thank James and Brett for the informative presentation today, and just like to let you know that there will be more webinars from the Southern Fire Exchange on prescribed fire. You can see the next series is on smoke management, and you also see how to connect with the prescribed fire efforts. So to finish out today's webinar, I want to let you know that you have to complete the satisfaction survey that's pushed out in the window, and then you take and pass the short quiz at the end of the webinar. to go ahead and get the continuing education credits. And even if you're not getting education credits, we do ask that you do complete the satisfaction survey so we can know whether we're serving your needs or not. So you can see what the next step is. So what I'm going to do is I'm going to put this link in the chat window, the chat box, and then I'm going to push it out. And once you get that, it should go ahead and automatically move your computer to the next screen. Ooh. Let's make sure this is the right link real quick. Okay, and now I'm pushing it out in the window. And so everyone should now have that link. And if you have any questions, please let me know. And I'm signing off now. Thank you.